Let's look at the titration gizmo on the Explore Learning website. We'll launch the gizmo, and after a second, we'll see our gizmo. Here we have the titrant, the liquid to be titrated in the burette. This vertical thing here is called the burette. And the flask is our unknown analyte. And here, the flask is already swirling because there's a magnetic swirler at the bottom of this flask. The flask right now is yellow because there's an indicator called bromothymol blue added to it right now. We can look here on the right side of the burette, and we see there's a valve or a stopcock. At the if the handle is on the bottom, there is no titrant being added. If the handle is in the middle, the titrant is slowly being added. And if the handle is at the very top, the titrant is quickly being added. So let's begin the experiment. We'll reset everything just to make sure all the numbers are correct. Right now, the burette is at 0.00 milliliters, and it contains 1 mole per liter of NaOH. And the flask is 100 milliliters of hydrobromic acid of unknown concentration. We can begin our titration by rapidly adding our titrant. And then once there is some initial color change, we will slow the addition of the titrant. Right now, it's still rapidly dripping, and there's now a temporary color change, so we slowly add the titrant now. We'll continue to add titrant slowly until there is a permanent color change. We'll just have to wait for the permanent color of blue to show, and there it is. We'll stop our titration now, and we'll note that is 21 milliliters here, and we start at 0, so that means we've added 21 milliliters of our titrant. We can input this data into our worksheet. So here's a worksheet. The first set of values is the moles of HBr and the moles of NaOH from our balance equation. And our balance equation here is 1 to 1. So we can enter the values 1 and 1. The milliliters of NaOH we use, we can look at a burette, was 21 milliliters, 21.0 milliliters. And the amount of HBr we used was 100 milliliters. 100 milliliters. The concentration of our sodium hydroxide in moles per liter, or big M molarity, was 1.00, 1.00. We can use our gizmo to calculate the concentration of HBr, and it tells us it is 0.10 moles per liter. We can also use this check function to see if our answer is correct. And yes, the calculated concentration of HBr is 0.210 moles per liter, and it's actually equal to the actual value of 0.10 moles per liter. Lastly, we'll go into Tools and Shot, and then we can Control C or right click and copy image and insert that into our assignment. If you have any questions or comments, please let me know in the comments below.